Good morning. I hope you're doing well. I am doing quite well, I think. I think everything's coming along quite nicely. I am pretty keen for this live stream, to be honest. I think this is going to be a fun one. I've got not really anything too big in and of itself to present, but lots of little things. And I think these little things all added up should make for a fun live stream, I think. Yeah, let's get right into it. So this week we are discussing the construction of Jugglebot's next act. I love these ChatGPT images, they're so good. So yes, the biggest thing is, hello Darkman. The biggest thing this week is that I have been hard at work doing construction on Jugglebot. So last week I mentioned that I'm going to replace the magnetic joints, which I have all of them here, no longer on the robot with all this heft. I'm actually not really sure where to put these because they're just so big and heavy. So they're gone now, and we've got the new joints in. And this took a little while, but I think it was worth it. The other thing is that the hand motor is ready to go. I showed last week a design that I think looks cooler than the design that I ended up going with. I'll show you in a second what it actually looks like. But that's all in place and is ready. But I do have a couple things left to do before the hardware is ready to go fully yet. The first thing is I need to string up the hand. So that's not done yet, and I'll explain why in a second. I also need to do some wiring because everything before kind of, like that central hub in the middle of the base was a pretty useful point for like routing wiring around, and I need to figure out some better way to route both the CAN bus wires and the power wires, because I don't want these to be going like parallel to each other. They should be as far away from each other as they can, and I'm not really sure where to route things to do that. So we'll talk about that more in just a second. And there's more wiring that needs to be done for the hand motor and the encoder, but I don't think that should be too bad. I think that's just a matter of just sitting down and doing it. Yeah, so yeah, let's do a tour. I think it will be worth, if SolidWorks, oh my God. God, I'm getting really fed up with SolidWorks, to be honest. Oh shit, no, that's a spoiler. Pretend you didn't see that. Yeah, I want to give you a tour, I think on CAD first, and then I'll show you the actual robot just to see where the differences lie, or see how it looks in reality. Because I was actually surprised when I put this together. I was surprised by how different it looked to what I was expecting, which doesn't happen too often because obviously when you have it in CAD, it is the real thing. But yeah, I don't know, something about just like seeing it in real life, it changes the way that you view it, I think, at least for me. Yeah, so same as before, we've got the joints from last week. The biggest thing that I want to show you in CAD here is the hand motor, which previously, if I open up the base, previously I had this. This is what I was showing last week. I think this looks so nice. It's very cool, but unfortunately it takes up a bit too much vertical room, and I need that vertical room for something that I'll talk about in a little bit today. So I swapped over for this horizontal motor, and this gives me a little bit, like this takes up less vertical room. It's also a lot easier to route the cable because the cable just needs to, the string just needs to go down through this little hole here, in which there is PTFE tube, just to give it a little bit more slipperiness, and that just goes straight onto the spool. But before, if I had the vertical motor, I had to do this weird kind of shenanigans with like routing the cable, or the string around at weird angles. You will notice as well that there's only one hole and one spool, and I will talk about why that is the case in a sec. I guess useful, well, just to describe what is actually going on here and why it's got this kind of like house on it. First up, let's get rid of all these. Because previously I have made motor housings that are sort of similar to this, where there's like a thin plate. that is actually supporting the motor. And I've found that because the motor is so heavy, it tends to kind of like sag down a little bit. So I've added these bearings in here just to kind of like give it a bit more support on the backside. I don't know if that is really the best way to do that, but it seems to be working now, and it will mean that there's like no load on the encoder, like no mechanical load, which should be pretty good because I don't think the encoder is not supposed to be supporting mechanical loads. It has already though, I've noticed just from like me spinning it by hand, I have never actually powered this motor on, but just me spinning it by hand, there's like 2 trails on the motor. They're pretty faint, they're not super easy to see. I'll show you if I can see them later. But yeah, it's already leaving a mark on the motor itself, so I don't really know. I don't know, I'll have to keep an eye on it, I guess. And I have also added this house thing, that's what I've been calling it at least, made up of the carbon fiber tubes because, I don't know, I kind of wanted to use them. And this like printed hat thing. And this is so that this little assembly is protected from balls landing on it. And it should do a pretty good job. It's pretty strong, like I've given it some really solid whacks, and I haven't thrown the ball at it because I'm a little bit, I don't know, I don't want to deliberately break it if I don't have to. But that should be strong against balls landing on it. The spool itself won't be. I realized that yesterday when I was putting it all together, that a ball could land like on here, and that might do some damage, but we'll see. It should be pretty easy to just reprint those parts anyway. The biggest thing right now though is that I do not want to break any of my bits, any non-replaceable bits. So I don't want to break the motor, I don't want to break the encoder, and like the O drives and stuff, but they should be pretty safe in their houses. Yeah, and I guess relatedly, I have decided to put the O drive, the hand O drive, in its own separate thing over here, where I was toying with the idea last week. And I don't know, it looks alright. This isn't actually here in real life, that's off to the side somewhere. Did kind of ruin my symmetry a bit, which I'm a little bit annoyed about, but you know, that's alright. Yeah, so let's have a look at the actual robot now, because there are some things that I want to show you. So first up, for me at least, it's kind of hard to see this. It might not really come across this way in the camera view, but for me, it looks way more stout than it did before. Like it's definitely a lot shorter because these old joints were at the end here and then the platform attached onto the top. So the whole platform was raised up by like an extra 5 centimeters or so. But also the fact that these joints are now out from the platform, whereas before these magnet ones were like directly underneath. It's made the whole thing a lot more stout, which I think is good. It feels more stable, but we'll have to wait and see. And yeah, it's looking pretty good, I think. So some things that I want to draw attention to. One of them is that when I was restringing the platform, I got a little bit lazy and wanted to just like reuse as many parts as possible, including this little ratchet mechanism that you may remember from a little while ago. But I think these parts should be single use only because you can see it's lost like however many, like 4 of its prongs. So like this whole part is not engaging anymore. And it seems to be solid. Like, I don't know if you can hear that. Let me go a bit closer. Like these strings, quite tight. So I think it's fine. And it hasn't broken yet. So I think it should be all right, but I may need to reprint that to do it again. Yeah, just on the point of wiring, let's see if this can see everything. Blocks itself. What about up here? That's all right. Actually, let me move the whole thing over a bit and raise that up. There we go. Yeah. So previously I had the power going all the way around the outside, and that way it was like off to the side, and then the CAN bus, like the communications, went into the middle. And as far as the general, like if you were just looking from above, it would just look like the CAN bus was like a star, like a 3-pointed star coming out from the middle. And that meant that the CAN cables were as far away as possible from these power cables. But now that this motor is here and this O drive box is here, I'm not really sure how to route things. I'm thinking of just like adding the power from this box to this box. That should be pretty easy. But the CAN cables, like there's not really any clear, obvious way. And I'm fairly sure I want them to be quite far away from this motor as well as from the power cables, because that motor is going to be giving off all sorts of, I don't know, interference, and that might interfere with the communications, which I obviously don't want. So I don't know if I'm thinking I might like print little channels that I can route the CAN cables through, and I can just like cover the whole thing in this like cable sheath stuff, whatever it's called. I don't really know yet. Yeah. All my symmetry is wrecked. It's very frustrating. One other thing that I do want to mention now is that just as like I don't know, if anyone's ever doing anything similar to this, it's worth paying careful attention to the order in which you create these things. So, the order in which you construct them. So if I bring this a bit closer again, these joints in here, let me get that a bit better. These joints in here were fairly involved to put together because these are screwed into the carbon fiber tubes. You can see there's a little bolt. I don't know if you can really see that very well, but there's a bolt in there. And that meant that I had to put these end caps onto the carbon fiber tube and then drill holes in the carbon fiber tube using the 3D printed part as a guide. I messed up my tolerances when I printed these parts, and I didn't really want to reprint them, so I had to hammer these end caps onto the tubes, which I've been trying to avoid for a long time now, but I guess I just can't escape it. So I hammered these on, drilled the holes, and then I had that bit as fixed. But the tricky thing with this is that when this end cap is attached onto the carbon fiber tube, I can no longer access the bolt that's on the inside of here. So maybe I can show you in CAD just to give you a bit of a better idea. Let's go to this. Come on, SolidWorks. Open this up. And make a cut. Yeah, so you can see this is like the carbon fiber tube, the end cap that I was just talking about, and there's a bolt that runs up through the inside of it. And that meant that because I had to hammer these onto the tube, I had to construct this part of the joint before I did that. So that meant that I was hammering onto the joint, which was obviously not very great for it. But it also meant that stage had to be completed before I continued on. And the end result of this is that when I was attaching the last joint from the platform to the leg, for the first one, I could play around with it a little bit. Like once I attached it, I could test how tight the joint was and if I had to adjust the tension on the bolt that runs through between the platform and the joint. And that's really useful because I'm securing all of these with Loctite and I want them to be solid and never have to move. But if I over tighten them, then like, for example, with this joint, the U part clamps too hard and the joint doesn't have as much freedom to move. So I need to get the tension in the bolt just right. And that involves basically just creating the joint and then moving it around a little bit, seeing if it's good. And then if it is, leave it. If it's not, then tighten or loosen. And I could do that for the first one, fine, because I could just move the platform around. But as I started adding these joints on, they would all, because they're all already attached, I have less and less ability to move the platform around and test the flexibility of that joint. So by the last one, the only thing I could really do was like move the whole robot around, and by that point I can't really feel how free the specific joint that I'm interested in is to move. So what I should have done is gone in the reverse order and attached everything to the platform first and worked my way out from the platform, fixed up my tolerances so that I could then, like first up, drill the holes in the carbon fiber tube, construct the joints from the platform out, and then just slot these caps onto the tube and then bolt them in. That would have been so much easier. But by that point it was too late and I'd already Loctited half of the joints and I didn't want to have to reprint parts. So, you know, it should be good. It seems to move around pretty freely. So let me put the camera in a better spot. So that's good. I think it actually has more range of motion than it did before. Let me slide this out. yeah, the magnetic joints would get stuck sometimes in different positions. Like they would max out on their range of motion because they would hit, like the joint would hit this part. But these joints, these have a lot of range of motion. Like I can go all the way over. I mean, this point here is reaching the singularity of these joints. So like this one, I don't know if you can see that very well, but he's like twisting around a bit weirdly, and I don't really want to let go of it in this position, I think. But huge range of motion now. And the whole thing is very stiff. Like it's very good. I'm keen to have this moving around and controllable with the Space Mouse. Yeah, I think that was all that I wanted to mention on that. It just took so damn long. It was like the entirety of yesterday, and my back was so sore afterwards. Just so much like bending over because it's on the floor, and I can't really escape it being on the floor. So lots of bending over, lots of standing up, getting down. Yep, lots of good fun. Yeah, I'm pretty sure that's that. So let's go onwards and upwards. What's next? Yes, the fuse, the mechanical fuse that I'm going to use in Jugglebot is very, very, very cool design. And I have Euroka to thank for the idea of this in the last live stream. They suggested to have the fuse in line with the strings, and I think it's a phenomenal, and use like the weakness of printed parts between their layers as an advantage here. So just to recap, what I want is something that will go between the hand motor down here and the platform up here. Well, something along this line of strings that will mean that if the hand motor gets a bit too excited and just runs like crazy and like hits the end, that there's a part that will be easy to replace that will break before anything else breaks. Because if other things break, like I literally have no idea what would break if not a fuse. So what I wanted to do was add a fuse in so that we know what part will break, and it should be relatively easy to fix if it does break. And yeah, Euroka was, and actually one other thing before I continue with Euroka's suggestion, what we really, really want here is something that is perfectly 100% strong right up until it fails, and then it fails completely, rather than something that like stretches and then like has a bit of play and then breaks. Because I want this fuse to basically not be existent, or not affect the system at all until it breaks. That's its whole purpose, is just to break very quickly, very suddenly, with no like stretch time in between. And as far as I'm aware, that pretty well describes how things fail when, like how printed parts fail when you pull them apart between their layers. And I think Euroka's suggestion here was really good to make use of that. And yeah, I'll show. So Euroka's suggestion, the way that I've implemented it at least, looks like this. So there's this little like tower thing. This is actually upside down. So the 3 hand strings, maybe I can just show you in CAD actually. So the 3 hand strings all come down through these 3 holes, and each of them goes into this central part, and then I'll be making a loop in the end of each hole, which will pass through, like through here. Come on, SolidWorks. And then it will loop around these little arms here. And I've got a little example to show you what that looks like. I don't know how easy this will be to focus on. There we go. So you can see the string comes in. So this, imagine these are tied, like this will be tied as one loop, and that goes around that little arm. And there'll be 3 of those for the 3 hand strings. And this is quite strong. There's basically like, there should be very little load on this, on the little arm that sticks out, which means that that should not break off. I would be very surprised if it did. And the plan is to adjust the layer, like the perimeters around here. So as this goes up, right now this is set to like 100% infill and 3 perimeters. But my plan is that I can just adjust the number of perimeters that are in here to adjust the strength of this part. To test how so there's a big question with this, is that like how reliable are these paths going to be, and I want them to obviously be as reliable as possible or consistent as possible. Hello Noah, thanks for joining us. And my plan for testing this is to use my tug tower down here, which I haven't shown you guys yet, I don't think. And this is basically like a tensile testing machine. So the two stepper motors on the side drive those linear ball screws, and I can just attach things between here and here. And this is a load cell, so I'll be able to read out how much force is coming through. And yeah, the plan is just to basically put the fuse in here and then rip it apart and do that again and again and again with this like different number of primitives, different whatever, and yeah, test how strong they are. There is a big question for like how strong do I want these to be that I haven't resolved yet. I don't really actually know. I don't know. I feel like I want to just test a bunch with different primitives and just see how strong each of them is, and then just pick the one that seems the best. I don't know. I don't know how strong I actually want them. But they should be pretty adjustable. They are, I mean, it takes 11 minutes to print with like the maximum infill. The only tricky thing is that it is a little bit hard to print. Like you can see this one that I've got, one of the legs is a bit munted because it didn't, like this one here, didn't print properly. And that's not ideal. So I'm not really sure, I mean, maybe, I don't know, maybe I'll add a brim, or maybe I'll just make these little feet a little bit bigger, or get rid of the chamfer on them, give them a bit more contact area. I don't know, but yeah, by adjusting this primitives and infill, I should be able to adjust the strength of them. It would also be good if I could get rid of this, if I could get rid of the hook on the top, and that way, if one of these breaks, I can just super quickly grab one and put all the hoops in and then go, and then have like a similar sort of like hoop mechanism on the bottom here, but I don't really know how to do that without using this hook. I want to make these as quick and easy to replace as possible if or when they break, because I anticipate breaking quite a few of them. Yes, so thank you to Yoroka for that suggestion. It's a very, very good suggestion. I really like it. Let's go back to here. And we have an honorable mention to Sven, who was suggesting to add a shear pin in between the motor shaft and the spool that goes around the motor. I really like that idea. It should also be pretty easy to replace. I think that, so like the general idea is like to have the motor shaft and then a thing that goes around outside of it, the spool, and then have a pin that joins the two of them. And that way all of the torque is transferred between the motor shaft and the spool via that pin. And if that torque gets too high, then the pin will just shear and break. It might be a little bit annoying to like fish the broken bits of shear pin out from there. I don't know, but that should also be pretty easy to reset. So I do like that idea, but the main reason why, I don't know, there's a few reasons why I haven't gone for that. I think Yoroka's idea is a little bit more elegant and a little bit more fitting to my application, but I really do like this shear pin idea. Yes, so there is an implication of Yoroka's idea which relates to the fact that here we have the 3 hand strings coming into here. All of them will terminate here, and then we have just a single string coming out going down to the hand motor. And that is important because we need these 3 hand strings to be the exact same length. Otherwise, this hand, like the hand itself, will not move up and down straight. It will be at a weird angle. So that means that we need the hand string length adjusters. They need to be in the hand itself, or somewhere between the fuse and the hand itself, which if it's not in the hand, I don't know where we would put it. And this has some interesting problems with the hand itself, because it is very, very difficult to print. This is actually the second version. I didn't get a picture of the first version, but the first version basically just didn't have these bits down the bottom. And perhaps unsurprisingly, this was printed like the way that it's facing here. Perhaps unsurprisingly, these arms got to about here and then they just broke off the print bed. That didn't work. So I tried adding this little, like, I don't know what you would call that, strip between them to give it a bit more traction. But that also didn't work. As we can see here, it pulled up and got all sorts of munted. It just didn't work. So I have upgraded it and added these little walls on, and this did print. So I've got the actual thing here, it worked. However, I don't know, my printer's not the best at doing overhangs. So this was after cleaning it up, and you can still see there's a bit of crap in there. And as I found out this morning when I actually tried using this the way that it's supposed to be used, that crap that's in there is too much. It gets in the way and doesn't allow this part to slide back and forth, because this is how the hand string length adjuster will be working now. The string comes into here, it goes through this hole, it will go through this hole, up around the top, and then be secured on with a bolt that goes through here. So same as usual with all of my other things, the string will just wrap around the bolt will be clamped, and the string won't be able to move. This hole down here is for a bolt that will run through from the outside of the hand all the way through, and there will be a nut in here that will just be free to spin, that will be Loctited on. And in that way, the bolt will be able to spin, but the bolt itself won't be going anywhere, and that will make this part slide along the length of the bolt. So by doing this, I'm expecting it to be quite tedious getting the string actually in here, but hopefully if the fuse works well, I only need to do this once and I'll never need to do it again. At least like setting them in. Adjusting the position will be pretty easy to do, but putting the string in I think is, yeah, we'll see. But even before that, the tolerance here is quite small. I think it's like 0.5 millimeter or something. Like it's, yeah, that's from the face. Oh, actually no, that's from the edge. Yeah, less than 1 millimeter in any event. And all of the crap that's underneath the overhang in here has meant that there's not enough tolerance there. So I don't know what I'm going to do. Maybe just make this bit a bit thinner, maybe cut a little bit off the top of this guy, but that can't be too much smaller because otherwise it won't print. I don't know, lots of trade-offs. Yeah, this is going to be finicky as to make. I'm kind of curious to know if I just had a different printer, if this would work well. I'm considering sending this to someone that I know that has the bamboo printer and see if that can do it any better. I don't know. If you have any thoughts for how to make this length adjuster in the hand so that it can print well, I'm all ears. I also obviously want this to be as light as possible and everything else, but I don't know. It's printed stuff, so it shouldn't be too heavy anyway. Yeah. Cool. Okay, so that is most of the updates. Well, that's all the updates for the actual, like what I've been doing this week. But there are a couple other things that I want to talk about because, yeah, I think they're pretty important. So, first one is that I have heard from a few people that they have been watching these streams or like following the project or whatever and have come up with different ideas and suggestions for me, but have found that it's just too much to write out. And I fully understand that. Like a lot of these ideas are fairly technical, and technical things often require a lot of verbiage to communicate. So yeah, I fully appreciate that, but I'm wondering if anyone has any ideas for how I can make it easier for you guys to give me suggestions. I want that process to be as seamless as possible because I want to be getting as many suggestions from you guys as possible. Because Jugglebot is still very young. I think some people in some projects get very attached to them and they don't really want to, I don't know, feel like they want to have like full ownership of the project and that sort of thing. For me, at least yeah, in general, Jugglebot is super young. The plans for this project are far, far, far out from where we are now. We're still at like the tip of the iceberg of what's going to happen here. And my aim for this project is to get into the distance from where we are now. I don't really care about any of these specific problems. I like all of this. I am more than happy to have as many suggestions as I can to improve these things. All I want to do is improve this stuff as fast as I possibly can because I want to get to where the Jugglebot is going fast. I have no, I don't know, desires to like solve all the problems myself. That doesn't interest me. Like I will, if I have to, because that has to be done to get the project to where I want it to get it to go. But yeah. So, yeah, I don't know how to make these things easier. I was thinking of making like a form or something that I can add as a link in the description to all these videos, and that way you can just like click on the form and then, I don't know what I would put in the form. That's the thing. I don't know how that would be different to like the YouTube comments. Or having like if there's like a version of ChatGPT that I could make that was like how websites have like chatbots, and someone could just quickly type in like a few dot points and then that can bring it out to like a full paragraph that the audience member can just like check over, make sure it's correct, and then send off. I don't know. But I want lots of suggestions. Especially if it's something important, if you see something important and you're like, hang on, should Harrison be doing that? Please let me know. I don't want to be faffing around at this stage. I want to just get going. And also, like, I've got other ideas for like post Jugglebot as well. I'm anticipating Jugglebot being at least a couple more years to get to where I want it to go. But there are other, in some ways, cooler, I don't know, other at least as cool projects that I really want to get to, but Jugglebot's first. It's priority number one. Yeah. And very related to this, I have been keeping a list of people who have been super helpful for this project, and I don't know what to do with it. I've got this list, and yeah, I don't really have any immediate plans right now. Everything that I've thought of, I don't want to gamify things. I don't want people to feel like, oh, I have to do this and this to like get on the list. So I don't want to make it too like competitive, but also I want to be able to show that I'm grateful for people's suggestions. And yeah, I don't really know what to do with this. If you have any thoughts on like how I can thank people, then yeah, I would love to know. Maybe, I don't know, just like a thing at the end of the PowerPoints, be like, I don't know, here's the list. I don't know. If you've got any ideas, I'm all ears. Yeah, okay, so there are a couple things as well that I have been thinking of. Doing construction and everything is a very tedious, time-consuming process, and during this process I have had a lot of time to think about what's next. And I would like to put in an order for the motors and the O drives and everything that I'll need for the cable version of Jugglebot. I'm anticipating the cable version being made this year, hopefully. The only way that wouldn't happen is if this version of Jugglebot goes really, really well, which I guess would be a good problem to have. But at some point I'm anticipating moving over to a cable robot, as you're probably aware. And I want to get all the stuff for that so that I just have it ready to go when I need it, rather than having to wait for ages for it to arrive. So I've got some questions for you all, because I don't really know what I'm doing with a lot of this stuff. One of them is that I'm wondering if brushless DC motors vary very much as you pay more or less for them. So the motors that I have now are from O-Drive, and I've been thinking of getting O-Drive branded motors. I've been thinking of getting some of the same ones as well as some other ones. But they're pretty expensive, and they don't have the ones that I would want in the stock that I need right now. So I've been looking at other places like Hobby King, and I probably won't go as far as AliExpress. I think I want a bit more quality control than AliExpress can offer. Unless you have had really good experiences with AliExpress and motors. I use AliExpress pretty much exclusively for like bolts and nuts and stuff, which I actually just had an order arrive yesterday, which is exciting. But anything like meaningful or complicated, I tend to try to avoid AliExpress just because I know that their quality control is questionable. Yeah, if Hobby King's outdated, if you have any other suggestions for where to get motors, I probably want in the very low kV range. Like these are 150, I'm pretty sure, and the other ones that I was looking at are 100. But yeah, if you've got any suggestions for where to buy motors, I would love to know. I'm pretty set on the O-Drives themselves from O-Drive, because O-Drives they're pretty good. But yeah, the motors themselves, I don't know. I would love if I could save on my O-Drive order by buying cheaper motors, because they're not super cheap, and also getting them shipped from like Europe or wherever they are to Australia takes quite a while. My last ones were like 3 months or something stupid. Yeah, the other thing is, this is something that I don't know, I've just thrown in pretty quickly here. The ODrive Pro, which is the one that I'm planning on moving to, is designed to be used with a battery. And if you don't have a battery, then you need what's called a Regen clamp to basically do what the brake resistor is doing in my current version of Jugglebot, which is to say, if, using the case of Jugglebot, if Jugglebot is moving down really quickly and I need to stop it from moving down and want to brake it, then the motors need to spin. Basically, the motors need to act as a generator to absorb that power, and that power has to go somewhere. My power supply is not at all happy about power being sent into it. It likes to send power out. And so you need a thing called a Regen clamp to stop that power going back. And yeah, that's about as far as my knowledge on this topic goes. If you have any, I don't know, if there's anything I need to be aware of when looking for Regen clamps, please let me know before I buy them, which will probably be soon. I don't know. The ODrive, I saw in one of the forums, the ODrive people were recommending this one, which is 50 watts, which, I don't know, seems all right. And I think, so looking at the image, it looks like you connect the power into here, like the power supply, and then for each of these V outs, like there's 3 V outs, I think that I could have like one ODrive connected into each of these, I think. Or would I just have all 6 ODrives connected to one V out? I'm pretty sure it's one into each, which would mean I would need 2 of these at least. But yeah, I don't know. If there's anything I need to be aware of with Regen clamps, please let me know. It would be nice. Yeah, thank you for Darkman for T-Motor. Do you know if they ship to Australia? That would be ideal. But T-Motor, I'd not heard of them. Let me quickly write that down. Cool, okay. So, final thing for today, which I think will be an interesting thing. Oh, come on. Hopefully that wasn't too loud. A new joint has appeared. That took longer than it ought to get together. I hope the audio worked there as well. I have no way of knowing if it did or it didn't. It played the smash. Yeah, so one thing that I noticed with the robot when I finally finished putting it together yesterday, I was looking at it and I thought, where are we? There we are. I thought, if there is load, oh, this is so hard to hold stuff. Let me just put that there. If the load is coming down from here, then these joints are all off to the side, which means that all of that load is kind of like bending the joints in a little bit, which doesn't really seem ideal. Like, I think it's fine now because like the joints are very, very solid, and I think it's fine now, but these parts will fatigue over time, and I'm expecting them to slowly develop a bit of play as that like levering force I don't know, fatigues them. And I was thinking that there might be another way to do these joints. And this was only last night that I had this idea, so it's very not fleshed out yet. But, oh, fuck off, SolidWorks. Alright, SolidWorks has crashed, so... Oh, no, it hasn't. God. SolidWorks is driving me mad. The program itself is so good, but, like, everything else, all of, like, the background stuff is just crap. Anyway, yeah, so I was thinking if, rather than having these joints be the way that they are here, when it will update. Yeah, rather than having them out the side here, I was thinking if it would be possible to have a joint that looks like this. So this part is the platform node. This joint can roll around the bearing that's not here right now, but imagine it is there. This joint can go that way, and this one spins that you can't really see. And this seems like it would be much more robust against that fatiguing force that I said before, because all of the load will be directly straight through the leg through here. And yeah, My only question is that I don't know if this will actually allow the Stewart platform to move in all of the ways that I want it to move. So, I'm thinking, I only made this very quickly last night. I'm thinking, as a way for me to actually make sure I do Jugglebot related work after the stream, because usually I just kind of faff around for a bit. As a way to force me to do it, I'm thinking we can do it now live in the stream. Just make a quick assembly of this and see what moving it around does. So yeah, I want to get on with that. And because the main part of the stream is over, I want to add some music too, so we can all listen to some nice tracks. And actually, yeah. I didn't really pick a theme. I don't know. Do you guys have any? What genres? Cinematic score is alright. What's in trending? Let's just go through trending. Hopefully you have music now as well. Cool. All right. Yeah. So I want to do similar to what we did in the stream before, where I was working on CAD stuff. I think it's fun to do this with an audience, and this will actually make sure that I get it done. And actually, maybe no, I'll look at the T-mode stuff a bit later. Sunny sky. Cool. Thank you, Darkman. Let me write that one down as well. Actually, there's one other thing as well that's very closely related to the fact that this stream is kind of a bit all over the place, is that I really want to add timestamps to... Is that music a bit loud? Looks like it might be a bit loud. I really want to add timestamps to these streams so that people who watch them later can just kind of like flick through and see the chapters and make it a bit easier for later viewers. But I'm not really sure. I don't want to have to watch the stream again myself later on to add the timestamps in, because that will obviously take a while. But I'm not really sure of a good way to do it. I was trying to get the transcript of the video, which I could then put into like ChatGPT or similar, and then have it categorize all of the stuff that I was talking about into the chapters, and then I could just, and like ideally with timestamps as well, and then I could just upload that as the chapter markers. But that didn't work. Getting the transcript out from YouTube was tricky to do, and if you wait for YouTube's transcript to be done, it's like, I don't know, it was like a week or something after the live stream, in which case most people have already watched it anyway. So I want this to be something that's like done as quickly after the live stream is done as possible, with as little effort as possible. So in this vein, this week I added like slide numbers to all my slides. So I was thinking that I can go through and like change all, and like based on those numbers I can figure out how to, like, when things are done. But I don't know. If you have any thoughts on how to do that better, then I would love to know. Also, my comments were a bit delayed then. That was a bit weird. So sorry, John, if you commented a while ago. Rotation around the axis of the actuator. Well, this would spin in here. So this, let me put me back. This between here and here can rotate. It's just you can't see it. Maybe we can actually, let's give this some texture so we can see that. I don't know what's a stupid looking. Let's make a fabric. Also, if you have a music choice, let me know. I'm taking requests. It's not gonna be easy to see. I want like a vertical texture. Gemstones. Oh, come on. There's an obvious one. Let's do carbon fiber. It's easy. What is carbon fiber? Plastic. Miscellaneous. Okay, let's do that. As long as it's obvious. So yeah, this can spin in here. Is the TLDR. Okay, cool. Thank you for checking that, Darkman. Spherical rod end would be ideal if you could get enough rotation. Yeah, I have these ball joints that I bought. These are like the super old version that I was using, but yeah, their range of motion is not nearly enough. And because they attach with like this weird hex shape, you have to be really, really careful with how that mates with the platform nodes. That was a bit, they were, yeah, too limiting to be very usable. I'm gonna guess that Meshuggah Bleed is a pretty intense song based on both of those words. I don't know if I'm in the mood for intense. Hobby Wing. I have not heard of Hobby Wing. Yes, thrust, that is a very good point actually. I had not considered that I would need a thrust bearing there, but you are absolutely right that I would. Yeah, cool. All right, so let's just add another of these. That goes onto there. This goes onto here. That's good. We want another one of these. This and this. Not that, that's wrong. Yeah, my goal here, I just want to basically construct this as though it were the actual platform and just see if it can move the way that I want it to move, because I'm actually not sure. Get out of here, spam caller. And obviously, like, obviously all of these geometries are very loose, let's say. This is very much just a demo just to see if this actually works. Because yeah, these will have to change a bit. Okay, cool. So let's add a base. Let's make a new part. And to make it as easy as possible, let's just make it hexagon. I don't know, 50. Something nice and arbitrary. Obviously the actual base is not a hexagon, but again, doesn't really matter. And because SolidWorks is nice and is only in geometry land, I don't need to do things as properly as I might otherwise need to. Nice. Good to hear. Dine? Did I do this right? Yes. I'll have my macros. Macros, what the fuck is that? Let's pattern this. Oh. So I just want to put some points down so that I can use those as like the base. Dine like wine. Nice. Is that like based on dinosaurs? Can I pattern a point? No, I can't. That's annoying. I guess I'll just do it in the sketch. Even though this really triggers me. If anyone's like learning SolidWorks, I strongly recommend avoiding doing your patterning and your mirroring and all that sort of stuff in a sketch. It is so much nicer to do it in the features rather than in the sketch, because you can actually edit them afterwards. Are they green or blue? They are green. Cool. Okay. Don't need you anymore. Don't need you anymore. All right. face. And actually that will be the main boy. Can you just add, so hooks, can you just add like in Google site:/au and it will only show like .com.au sites? Is that a thing? If so, it's amazing. I like to be tidy. Put all my things in folders. Although I'm probably not going to do that for the rest because it takes too long. Just do the first one. Okay, so the plan here is to be as lazy as possible and have it still work. So I want to show temporary axes and mate these onto here. Come on, let me pick a point. Fuck, it's the wrong way around. What? Yeah, let's just do it properly. So I don't want that, I want that one to go to there. Actually, I'm just going to quickly rearrange my windows because I don't want to be looking down all the time. So let's change this. Ah, never mind. Alright, I'll just look down. I don't have a window capture set up on OBS right now. Okay. I want to try to get things roughly positioned so that when I add more stuff, it doesn't crap itself straight away. Also, if you're curious, if you right-click and move parts around, then that will rotate them rather than just translating them, which is handy. But it's very good to know hooks. Thank you for that tip. I like that. Okay, so now we need more platform bits. So this will be... Let's make sure that this is actually the right geometry. I did this very quickly last night. Actually it is. Nice. So we should, I think, that one's easy. Should be coincident. Nice! And also I'm making new parts by holding Control and dragging off. Let's go there. Cool. Yeah, let's just make it simple. Make all these touch. This is the dodgiest mate ever. That's okay. Yeah, cool. All right, now more of these. Actually, we can do this faster. And the cool thing about the control clicking is, so if I control, click and drag, as I said before, off of this round surface, and then I bring it onto another round surface, it like automatically does the mate for you. So now that like rotation mate is already done. Let's fix this temporarily. So now this can rotate. So let's do that for all of them. There, yes. One there, yes. One there, yes. We don't need you anymore. Now the widths. Yeah, I think if this works, I think this joint structure should be quite good. But part of me is like kind of doesn't want to know if this will actually work, because then it will be more stuff to do to improve this version of Jugglebot rather than moving over to the cable robot. So I don't know. It does depend a lot on how this robot actually performs, but I find like when I get an idea in my head, like one like this at least, especially mechanical things for me, just can't not think about it. And I know if I don't test this to see if it works or not, I will be thinking about this for a long time. What? No. Oh, okay, this one's not doing the automatic mating. Lazy SolidWorks. I love the width, mate. Definitely top tier, mate, for sure. I would also recommend, if you're doing stuff similar to this in SolidWorks, I find it to be a good idea to do all of the same sort of mating at the same time. It's like I'll do like all of one joint together, and then the next joint all together, and the next joint all together. And that way, when you go into the mate folder, you can just like work through joint by joint. But right now I'm just kind of doing whatever, because this is just I don't know, template assembly. I'm also very curious to see, so before I do the main Jugglebot video on this version of Jugglebot, one of the things that I want to do is go back to my big Jugglebot assembly, this one, and actually put in all of the bolts and everything, because like I've got some bolts, but I've definitely missed far more bolts than I actually have. Like there's one here, there's one here, there's one here. So many bolts, especially in this leg part. Like I haven't put any in there. And I wanted to see like how many actual physical objects are in this robot. I think it's quite a few. This assembly right now has 540 parts, I'm pretty sure. And that's, as I said, without any of the bolts, or with missing most of the bolts. So I reckon the whole thing, surely well over 1,000, which is pretty crazy to think about. 1,000 things are together right behind me, in like a structured way as well. There we go, now you can do it. Where did that go? There it is. What are you doing? This is really like Pirates of the Caribbean vibes, isn't it? All right, 2 more. And hopefully next week, I suspect, I think, I don't know, it depends how much other work I have to get done, but I think we should be able to test the throwing and catching, I think, because the control for this my plan is just keep everything super simple and just, yeah, move, throw, move, catch. And I think doing that, I think implementing that control stuff should be pretty straightforward. So I'm hopeful. My biggest qualm, or biggest like reservation right now, I think, is the wiring. So I'm not really sure how to do that, but we'll see how that goes. All right. Oh, whoops, I thought they were all the same. Which one's fixed? Okay, so now we can bring back these. This guy goes to here. This guy goes to here. Okay, cool. That actually looks like it should work. Yeah, I've noticed this last night when I made this, that I think that I'll probably, if I do make the joints like this, I think I'll probably have to offset this, like this axis that goes through here, that this one rotates around. I think I'll probably move that down a little bit below the platform node so that it doesn't hit when we go into situations like that. Like these two are colliding right now. But I think if it's offset down a little bit, maybe let's give that a go. What is the easiest way to do this? Let's go. Let me think. Figuring out CAD, I find CAD so interesting. Just like there's so many different ways you can make the parts that you want to make. But it's always a matter of like, I feel like it's always worth spending a bit of time having to think about it before you actually jump into it, because otherwise you just kind of can fumble around a bit. So I want to move this down relative to the rest. This might be a bit tedious, but it's okay. Let's leave that. And I want to change as little of the rest of it as possible, because all of my mates that I've just done are based on like this surface and like whatever that point was off to the side. So I want to leave those so I don't have to redo the mates. Let's just do it dodgy. Doesn't matter. Let's go, I don't know, 50, why not? And this to be in the middle, and this gap to be, I don't know, 5, why not? And that can also be 5. This should go to here. Oh, whoops. Come on, SolidWorks. Sometimes it's really good at inferring what you're trying to do, and it like if you cut a line in the right spot, then it will like match up the rest of them to kind of like keep the I don't know, arrangements, the relationships that you had before, but sometimes it doesn't. How about wiring under the base? Oh, I really don't want to move, I don't want to do anything to the base, because right now that base is just on the floor, and it's really nice having it on the floor because it means I can just like slide it around really easily, because I do move it around quite a bit. And also, like, I don't know how I would access the bottom right now. Like this, the whole thing is quite heavy, and I don't really have any way to like, I can't like turn it upside down to cut anything out. If I did plan for this beforehand and had like CNC'd channels in the bottom, that would be pretty sweet. But then also access is a problem. It's a good idea. Raise the base on rubber feet. Yeah. Yeah. I also, so another thing is that I don't want to, especially for the power cables, I don't think I actually have very much of the cable that I've used left. I'm pretty sure it's all there, and I don't want to have to change my cuts that I've made too much. So I'm thinking the power cable, I want to keep it largely where it is. The can, maybe I could do the can like the whole way around the perimeter of the whole thing. I don't know, because the can cables are pretty easy. I've got a bunch of those lengths extra. So I want to move that down. What is that on? Let's make a plane between here and here. Come on. And put you. These are very different vibe songs, hey? I do like a good piano there, a good bit of piano. Cool, okay, that should be fine. Let's try this. This is obviously not how it would look in reality. Oh, so good, just like that, boom. All right, let's make things a bit bigger to give it a bit more. What's the actual diameter of Jugglebot? 450, I think. Let's check. $820. God, it's huge. Way bigger. Let's go 800. Boom. And the platform. Let's say this is this minus 20. And this. Actually, let's change the mates around. And you can see the importance of having folders. Like, can you imagine? Like this, this is pretty simple. And if I wasn't using folders, this would be such a mess. Like all these folders are all for different parts. Cannot imagine the chaos that would be around if I was not using folders. It'd be so hard to find stuff. Yeah, so I want to change those mates. Maybe it would have been good if I did put them in folders. How can we set these to be far apart? I know. Do a sketch on here. Actually, let's just do it in this. Let's have a point. We could do the same mate that I did before, just with a different point. It's tricky as well, like, to know where to take your measurements relative to, because that makes a big difference. And it's not always super obvious. Oh, I need one on the other side. Actually, no, this will work. Put this onto here. Boom. And then I can increase that distance. Nice. Cool, let's make these a bit longer. All right. Oh. No, you can just click on that. Okay, so that's a problem. If it is lower, there is a collision there on even just like a slight tilt. It's a pretty funny song. I guess, like, it wouldn't be too tricky. This is a very distracting song. Sorry, Mr. Spanish Man. Yeah, I don't know about that one as well. Not my vibe. So if we cut this out, that will obviously help that collision. But it'll be so much weaker. Shouldn't the gaps be larger to allow full 180-degree rotation? Which gaps? These gaps? Or are you talking about the gap that I just cut out the top bit from? Actually, that's a good idea, rather than cutting that out, because cutting it out would weaken it a lot. Let's instead make that bigger. Yeah, I think this is what you meant. Yeah, absolutely. That is cool. I have a feeling that this, oh my god, should work. Interesting. Obviously, I'll have to play around with specific geometries, but like that is fine. I feel like that collision is not a problem. Get out of, what are you doing, Microsoft Search? Yeah, okay, this will be interesting to apply onto here because I've already got a lot of other stuff going on in these. Like there's a bunch of these tubes go in quite a bit. But the same here. Sorry, there's a bit of a delay, Gene. Yeah, this gap, yeah, I think, yeah, so I can make that like 40. But obviously I don't want to make it too big because then it will be much weaker. I like that. I really like this. I think these joints should be a lot better. So I would need, as John was suggesting before, these would definitely need to be a thrust bearing, which for those who don't know, are a pretty cool bearing actually. Let me get a picture. They allow you, they can like support loads that a bearing normally does, as well as axial loads. Actually no, sorry, I'm thinking of angular contact, which is probably the type of bearing I would use, I think. So they look like this, and I would have, I just want the picture. Yeah, I would have like this top bit up the top, and that way like, as you push in, the like cone part will like, I don't know, push up against itself and it will support that axial load. So yeah, I think angular contact bearings in here. These can just be normal, this is a normal bearing. It would be tricky to get this to work for the actual platform node, so it's strong. But I really like that. Yeah, I think I will leave the joints as they currently are, just for now, see if it becomes a problem, and then maybe move to this. I'm glad that we did this though. That was very, I don't know, I feel happy that worked, because I had a suspicion, what is this song? I had a suspicion that this would work, but part of me was like, what if there's something you're not thinking of? But it works, cool. One thing as well, that in case it's not obvious, something that I have gone to a fair amount of effort to ensure is the case with these joints, and would also be the case with these new joints, is that to make it work kinematically a little bit more easily, so that we have a distinct point about which that node can like rotate and everything, we want all axes of rotation to coincide at one spot, only one spot. So, for example, where's a good angle? So if we have a look at just this, I think that's everything. Yep. Then we can see, oh, wrong thing. We can see that there's one axis of rotation along here, because this tube, the black tube, can rotate with respect to this like outer cylinder part. We have a second axis of rotation through here, along like with these two bearings. And we have a third axis of rotation along here through this bearing. And if I drew that properly, all three coincide on one spot. And this is critical for having the kinematics work. If these are offset, then it just makes everything so much more difficult. I actually don't even really know how to deal with that kinematically, but I know it's a lot more annoying. Because when we go to, if you remember, this is for the long time viewers, if you remember, we have like the length is equal to the translation of the platform plus the rotation times the platform nodes minus the leg length. Oh, sorry, minus the location of the base joints. For this equation to work so that we can calculate how long all the legs need to be, these points need to be coincident. You need to have a specific point. This P here is the location of this point for all of the legs. Yeah, and if that point is not a point, like if the three axes of rotation are all askew from each other so they don't intersect, it just makes your life so much more annoying. And to prove to you that this is indeed the case for the other joints, we can go to here, have a look at this. I won't bother hiding other stuff. You can see, again, there's an axis of rotation along the length because this, there's like bearings and stuff in here that allow for that to happen. There's another axis of rotation through, let me change colors again. There's another one through this bolt that you can see the end of. And the third one is through here. And they all intersect at this point here, right in the middle of the whole thing. It took me a little while to come up with a design that was the case for, because it's tricky to make sure that happens and have everything like still be strong and still be makeable. I don't know if I vibe this song or that, to be honest. Yeah, that took a while, and I'm glad that it works. Noah, as far as the timestamps go, make a quick note of the timestamp in OBS as you get to each slide. Yeah, that's a good idea. I kind of want something to be like semi-automated though, so that I don't need to like write anything down, because there's already enough stuff that I'm kind of focusing on and like trying to make sure that I pull in the right things at the right time. I don't know if I want to add another like step that would have to be done at each slide. I don't know. If that was automatable, that would be amazing. Yeah, cool. That worked. I don't really know. Yeah, cool. I'm happy with this. Yeah, that was about all I wanted to test right now. I probably will faff around for the rest of the day. I don't know if I'm going to be doing Jugglebot stuff. It's so like, live streaming really takes it out of you a lot more than I would have thought. It's definitely a fairly involved process. It's a lot of fun though. Actually, I guess I'll sort out all my nuts and bolts and stuff that just arrived. Yeah, cool. Thank you for joining in, everyone. I hope that you enjoyed this as much as I did. And I hope that you are delighted by these new joints as much as I am. I think they're very cool. I'm very keen to know that they exist, at least. Part of me really would want to, part of me is definitely very like mechanically minded. I'm going to stop the music now. And really wants to just kind of like make mechanical things as much as I can. But the bigger part of me knows that, as I said before, this project has a long way to go and I can't spend too much time faffing around on these little minor improvements if they're not needed. Yeah, cool. All right, hopefully next week we will have the throw attempt, number 2. I am much more hopeful about this time. I think this is much more likely to work than last time was. Keeping everything simple, the hand motor should be able to throw to like a bit over a meter, which will give ample time to move over and catch the ball. I'm seriously considering, well, I'm hopeful that 2 balls in one hand should work, because like if you watch me do it, like you don't need to move your hand that fast, especially if the balls are going high. Like the side to side motion of your hand is really not that much. The up and down is a fair bit, but now that we've separated the throwing action from the moving motion, it should be able to do 2 in one hand. And honestly, even 3 in one hand. Like I can scarcely do 3 balls in one hand under this ceiling. I won't do it now because I don't want to damage anything, but maybe 3 balls, maybe. I'm pretty confident I can do 2 though. And that would be good. That would tick off 2 of the milestones on my milestone list, which will be exciting. Fingers crossed. Cool. All right. Well, thank you for watching, and good luck with everything that you are doing. And until the next week, have a good one.